Okay, lesson 1.3, the 12 basic functions. I cannot stress enough how good it is to be familiar with these graphs. Okay, I'll refer to these all throughout this year. In calculus, I still refer to lesson 1.3 in pre-cal where we learn those 12 basic graphs. Okay, so this is a good lesson that just, you need to be familiar with these. Now, some of these you are familiar with, right? Maybe not by name, the identity function. You're probably not familiar with it as the identity function, are you? However, when you look at that equation, y equals x, can you visualize what that is without your calculator? With a little thought process, y equals x is a what type of graph? What shape? Yeah, it's a line. It has a y-intercept of 0 and a slope of 1. Okay, so, I don't know, do I even need to graph that one on the calculator? Now, the idea of the identity function, it's y equals x. It's specifically a line with slope of 1 that goes through 0, 0. You can graph on the calculator. That's a piece of cake, right? So, make this official in your notes. Change it if you made any mistakes, of course, as we go. Okay, thoughts on the domain. How far to the left does this graph go? How far right? Infinitely, right? So, I'm doing mine in interval notation today. So, I'm going to write mine as negative infinity to positive infinity. Range. How far up and how far down does my graph go? Infinitely, right? So my range I'm going to write as negative infinity to positive infinity. Okay, so identity function. It's a line, but we call it the identity function. Okay, kind of a weird name for the next one, the squaring function. Y equals x squared. What do you guys call this? Parabola, yes? This is just that. This is a parabola. Now, obviously, there's lots of different parabolas, but the basic parabola is going to be the U shape that goes through 0, 0, right? Has a vertex at 0, 0. What kind of domain? How far left, how far right does this graph go? Yeah, as that graph is going up, it's going infinitely out. And so my domain, negative infinity to positive infinity. Okay? Range. How far low? How far low? How low and how high does this graph go? Okay, it doesn't go below 0, right? So my range is going to start, if I kind of am moving, my pen up here. The first y value I'm going to hit is there at the vertex of 0, 0. So that means my y values, we start having y values at 0, and they go to where? Infinity, right? Now, is 0 included? Yeah, because you can put 0 in for x and get 0 for y. So I'm going to use a bracket with 0 and 0 to infinity. Okay? Those first two, you should have had confidence as you went through them today, or as you went through these for e-learning, right? Okay, I got this. I can do this page, right? Cubing function. We've talked about that a little bit before this year, haven't we? It's not one we've done a lot with. Do you remember what the cubing function looks like? Y equals x cubed. Not that you do it by that name, but y equals x to the third. Got kind of that basic squiggle, right? It's increasing. It kind of does a jog at 0, 0 and then goes back up, or continues increasing. So, looks something like that, right? And again, it's about knowing the shape. We went into a graph that looks like this, and in fact, okay, this is a cubic graph, an x to the third. A little bit of vocabulary. that point at 0, 0 where it turns is called the point of inflection. So that's just a little bit of vocabulary, but where it changes from being curved down to curved up, which you guys we haven't talked about concavity, but okay. Domain. How far left and right is this graph going? Infinite. Okay. As it's going down, it's going infinitely left. As it's going up, it's going infinitely right. Speaking of up and down, how far up and down is it going? Infinitely also, right? So both domain and range, again, are negative infinity to positive infinity. Okay. First row was good, right? We knew what to do. We had some confidence on these. Like, yes, I can do these. Second row doesn't get too crazy. It's just a matter of if you can figure out what they're wanting you to write there. Okay. Reciprocal function. 1 divided by x. You can do a fraction, 1 over x, or you can do 1 divided by x. Mine shows up as this. Did you kind of figure out what it's doing? You have a curve in the first quadrant and in the third quadrant. Okay. And if you zoomed in, you might be able to see a little bit better. But that's kind of the idea of what your graph is doing. First and third quadrants. If you had a reflection, it might end up in the second and fourth quadrants instead. But there's 2 separate pieces in the reciprocal function. Let's see. You guys are pre-calc, so we haven't talked about what a hyperbola is yet. But that is part of our second semester. The fact that the shape of this graph, the 2 curves going opposite from each other, those are called a hyperbola. So we'll do a lot with hyperbola, maybe January. I want to say it happens usually right after Christmas, where we look at our conic sections. Now, what's happening here? What are the x and y axis acting as? Those are asymptotes, aren't they? Okay, x and y axis are acting as asymptotes. So based on the fact that they're asymptotes, what kind of domain do I have here? How far left is my graph going? How far right is my graph going? And what happens in the middle, right? So how far left and right is my graph going? It's going infinitely left and infinitely right, yes? The only deal is that we have this break in the middle, don't we? So we're going to go infinitely left, so negative infinity, up to, what's kind of our break point? If our break point is this asymptote, what is that what number represents that asymptote? 0. So for our domain, we're going to go negative infinity up to 0. 0 with a parenthesis or bracket. Parenthesis, because we're not going to touch 0, right? So we're going to go negative infinity to 0, union, and then guess what? 0 to infinity on the other side. And so what that domain is saying is that basically it's all the numbers except 0. And that's just because we can't have 0 in a denominator, folks. Now, what about range? As we read bottom to top on this graph, my graph is obviously going down to negative infinity. But what's happening? As it gets towards this x-axis, it's going off to the left. And what y value is it never going to include? That same old 0. But then up on the top side, we pick back up again. So we have y values, negative infinity, all the way up to 0. Jump over 0, because that's an asymptote, and then 0 to infinity. So our domain and range actually look the same this time. The difference is that domain is technically our x values and range is technically our y values. Y equals the square root of x. Were you guys able to graph this one okay? You found square root and put x under it. What's this look like? Yeah, it's half of a sideways parabola. And that is exactly what it is it's half of a sideways parabola. Because y equals the square root of x is the inverse of y equals x squared. So it starts there at 0, 0, and goes up and over. Domain. Where do my x values start? How far left can I go? 0. Yes, this graph starts at 0. And 0 to where? Infinity. Because when we look at what kind of x values can I put in, can I take the square root of 0? Yeah, I can take the square root of 0 and get 0. I can take the square root of 1, 2, 3. I can take them decimals. I just can't take the square root of negatives. And so that's why this graph doesn't exist over here. So my domain is 0 to infinity. Parentheses or bracket on that 0? Bracket, because I can include that. And if you were, it's one of those things. All year long, you see me. I look at the equation, but I also look at the graph. If you look at the graph, notice when I hit trace, it puts me right at 0, 0. If I move left, my y doesn't exist because I can't take the square root of a negative. If I move right, then I start getting values. What about range? How low can my graph go? First y value I'm going to run into here is 0 again, isn't it? A square root, I can't take the square root of a number and get a negative. So again, we're going to have 0 to, as this graph goes right, it's going up, right? Infinitely up. So 0 to infinity. What about 0? The square root of 0 is 0. So yes, 0 is included in both cases. Okay, e to the x, exponential function. I mentioned exponential function earlier, didn't I? When we were talking homework examples, because we had what, 1.5 to the x? And if you remember anything from Algebra 2, e is a number officially, right? It's that natural number, 2.718, so on and so forth. On your calculator, there's two different places I have found it. What I personally like to use is over here on the left, right above the ln button. That's where I like to go. Because it's e to the x, so it automatically, when I do that, it says e, and then it gives me an exponent. And usually we're putting in some kind of exponent there, aren't we? And so then I can type x. Some people also found e over here. And if you do e over there, the only difference is it doesn't go ahead and put in the exponent for you. So that e above the division symbol also works. I don't care what you use. They both mathematically will give you the same thing. So you have e to the x. Okay, did you figure out what that graph is doing? What's it doing at the x-axis? It's what? Yeah. Okay. That x-axis is acting as an asymptote again. So it's running along the x-axis. On your calculator, it looks like it's on the x-axis, doesn't it? Okay. So it's running along the x-axis, never touching, never crossing. Use your trace button to check it out. A typical exponential function, no shifts, no stretches, no shrinks. We'll cross through at 0, 1. That's a 1 I wrote down in there, if you can tell. Okay, domain. What kind of x values can I put in this exponent? How far left, how far right can my graph go? Is it running off the screen left, running off the screen right? Yeah, so my domain again is we're going to go back and say all reals, negative infinity or positive infinity. What about the range? How low? How high? What? 0 to infinity? Didn't we talk it doesn't cross the x-axis, right? And that represents 0. It doesn't cross, it doesn't touch the x-axis, but it does continue going infinitely up. So 0 to infinity, parenthesis or bracket at 0? Yeah. It's an asymptote. It's not touching that asymptote. So 0 to infinity. Now, that was the exponential function, e to some number. The inverse of e to some number is the natural log function. And in order to do natural log function, you just found your ln button and typed in x, didn't you? Finish parentheses, don't finish the parentheses, it'll graph it either way. Okay. What's this graph doing here? It's definitely running off to the right, isn't it? Notice when I hit trace, I get 0 blank. We can't do the natural log of a 0 there. And when I start going right, it hops on right there and gives me values, yes? Okay, this is one where the calculator is a little misleading. Your y-axis is acting as a horizontal asymptote is what's happening here. Not horizontal, vertical, excuse my speech there. So it may appear that the graph kind of stops there around -1, -2, but it doesn't. Okay, this graph is going infinitely down. Okay, so it is going infinitely down, infinitely up. It's just my x values are restricted there. So for the domain, oh, and by the way, that is going to cross the x-axis at 1. Kind of like the previous one crossed the y-axis at 1. Now we're crossing the x-axis at 1. Okay, domain. How far left does my graph go? Yeah, we don't start having x values until 0 to infinity, because my graph is going infinitely right. What are you doing at 0? Parenthesis. Range. How far up and down is this graph going? It's going down, isn't it? I've cleared that up for you. I told you this is an asymptote, so it is going infinitely down, and as it goes right, it's going infinitely up. So, range is negative infinity to positive infinity. Okay. How'd this one go? I'm trying to think. I didn't notice anybody having strange stuff, but I don't know. Okay, y equals sine x. You're going to find your SIN button and put in your x, and you're going to graph. And did everyone get the curvy thing? Up, down, up, down? Because it's possible you didn't. Because in order for you to get sine x, your calculator has to be in radian mode. But if you're all in radian mode, you all got the right thing. On my calculator, I know I'm in radian mode because look what it says right there. It says radian. As opposed to if you take physics, you want to be in degree mode most of the time. Okay, first semester doesn't really matter for us. When we get in trig, we'll go back and forth a lot between radian and degree mode. Okay, so if you ever need to change that, you just go into mode here, and it's the, what, fourth thing down. So if you have one of the calculators you can't see at the top, I don't know if it's radians or degrees. You go into mode, and notice radian is highlighted, so I'm in radians. I could arrow over and change it to degrees if I have to. Okay, so this sine graph, yes, it is a curve. And I'm going to draw mine a little bit different than what most of you guys were drawing. A sine curve, notice it's not going to go infinitely up or infinitely down, is it? These curves are as tall as 1 and as low as -1. The sine curve cuts through 0, 0, curves up, curves down, and one cycle of sine is 2 pi. And so that's what second semester we'll be graphing sine and cosine curves. And that's what we'll talk about. Okay, the other way, it goes down first, cuts back up. You know, those mins and maxes go all the way up to 1 and all the way down to -1. Now, I get it. Some of you guys, you drew a lot more, and that's fine. You know, if you drew a lot longer, you know, this is just the basic, you know, cycle. Okay, domain. How far left and right is this graph going on your calculator? It keeps going on and on both ways. Up, down, up, down, up, down. So my domain is, as you would guess, -infinity to +infinity. What about range? How low and high does this graph go? It goes as low as -1, doesn't it? Okay, if you zoomed in on your calculator, you'll be able to tell that. It goes as high as 1. Does it ever go past these? It does not. So my range is -1 to +1. Does it touch these? And I will tell you it does. So it's -1 to +1 with brackets. Now, what do you guys think when you graphed cosine? Did you wonder if maybe you made a mistake? If it, you know, it looks the same, very similar, doesn't it? If I leave my sine graph on my calculator and I graph cosine, which is just a matter of doing, cosine x. Again, you have to be in radians for it to graph right. Notice it is very much the same curve, isn't it? Except that it is shifted. I know it doesn't mean anything to you guys right now. It's a difference of pi over 2. It's a pi over 2 phase shift. Okay? So cosine has a lot of the same functions. It still goes as high as 1, as low as -1. The difference is that it starts up high at 1, goes down, comes back up. So that is what one cycle of cosine looks like. Same thing happens on the other side. And that does say -2 pi over there. So what would you guess about the domain and range? Yep, same as sine. It's going to go infinitely left, infinitely right. So domain is -infinity to +infinity. And the range goes as low as -1, as high as +1. And those are brackets. Okay. Absolute value function. If you remember how to graph absolute value, you can graph this, right? What shape did you get for absolute value? It's in alpha F2 if you're trying to do the shortcut. You get a V. That's not totally surprising, is it? Didn't we graph absolute value last year in Algebra 2? maybe exactly a year ago, actually, considering I just taught it to Algebra 2 last week. Okay, I taught it to them Wednesday, Thursday. So yes, it is an absolute value, V. Okay. Domain, how far left and right does this graph go? It's infinite, yes. V is extending infinitely left and right. What about range? How low does it go? The first place we start having y values are 0. Because at the vertex, 0, 0. So 0 to infinity. Is 0 included? Yes, so I'm going to use a bracket. Okay, I am running out of time, dang it. Let me skip over to the logistic function real quick because I think I'm going to have to do greatest integer tomorrow for your class. Logistic function. Y equals, I'm going to do a fraction bar because I've got a lot going on here. 1 over 1 plus e to the negative x. And I know I told you in class Thursday that that's what that said to give you a little bit of help there, didn't I? As I graph this, if you watch carefully, it's drawing there along the x-axis. Then it kind of goes up. And then, what's it drawing along there on the right side? Did you figure that out? If you start tracing over there and watch those y values, they get very close to 0.999999, but you can never get it to go up to 1. So, there's kind of two horizontal asymptotes. Now, keep in mind, I skipped a graph, right? So go off to your right here. It runs along the x-axis, around the origin, it kind of shifts up, and then it runs along over here. It is never going to go above 1, and it is never going to go below 0. So, domain, negative infinity to positive infinity. Okay? And range, it goes as low as 0, as high as 1. But it does not touch 0 and 1, so it's 0 to 1 with parentheses. Yes, Jacob? Oh, does it eventually touch 1 if you trace far enough?
No, it's like x equals 17.
Starts going, it gets to the point where and what it's doing is it's not technically touching 1, but your calculator's rounding it to be 1 eventually. So, okay. Now, I will explain to you tomorrow how to graph this, but real quick as you're on your way out, homework will not be due tomorrow. Whoops. This is the middle graph that I just skipped over. It looks like stair steps. So if you got stair steps, and I know I helped some people with how to graph it, some of you may have Googled it, you got the right thing. So I'll show you how to graph the stair steps tomorrow. Greatest integer function. You can start looking at homework if you want. It's just questions about these problems. So I'll do greatest integer function tomorrow. I'll go over, there's some questions on the back we can practice with, and I guess homework's not due tomorrow. I'm thinking quiz isn't going to happen until next week. Because by not getting through this today, not going to happen. Homework is on the board, in Schoology, in Skyward, if you need to write it down.
I submitted my the 1.3, and you'll see it on your graph on my calculator, and I got the domain and range, but for some reason I didn't get the graph.